Have you ever just stopped and wondered how our muscles do what they do? I mean, one second you're heaving a heavy box, and the next you're doing something super delicate like threading a needle? It's an incredible biological trick, right? Well, today we're going to pull back the curtain and look at the hidden control panel your brain is using to dial in the perfect amount of force for every single thing you do.
Seriously, think about that for a second. The very same muscles in your arm that you use to lift a heavy package are the ones you use to sign for it just moments later. How on earth does your body go from brute strength to fine, delicate control with the exact same equipment? So what's the secret? Well, that's exactly what we're diving into.
The secret is that your brain has this incredible hidden control panel. It's not just a simple on-off switch. No, it's way more sophisticated. It's like a sound engineer's mixing board with all these different dials and levers that are constantly being adjusted. Today, we're going to look at the four main controls on that panel, one by one.
Okay, first up on the control panel is maybe the most basic one, deciding how many muscle fibers you need for the job. You can think of your brain as a team manager, and its first decision is always, how many players do I need to send onto the field? Now, to get this, you have to know about something called a motor unit. This is the fundamental building block. See, a single nerve doesn't just talk to one muscle fiber, it's wired up to a whole group of them. And when that one nerve fires, that entire group, that whole team of fibers, contracts all at once. It's basically one on switch for a whole crew. And this is where it gets really cool. When you're just writing your name, your brain is super precise. It activates just a handful of these motor units. But what if you suddenly have to sprint to catch a bus? Your brain sounds the alarm and recruits a massive number of motor units, all firing together to give you that burst of power. And the difference here is it's just massive. Look at the number of units you need for writing versus what you need for an all-out sprint. It's a really smart system, right? Small job, you send in a small team. Huge job, you call in the entire army. Okay, so recruiting is step one, but that's not the whole story. Once you've got your team on the field, how do you tell them to play harder? That brings us to the second dial on our control panel. Your brain has another lever to pull, kind of like a volume knob or a force dial. This isn't about adding more players to the field. This is about cranking up the intensity of the players who are already there. And it does this by changing the speed, the frequency of the nerve signals it's sending out. So here's how that works. If your brain sends just one slow signal, you get a tiny, brief contraction, a little twitch. But as those signals start coming in faster and faster, the muscle can't relax in between. The twitches start to stack on top of each other, building up more and more force. And then, when the signals are coming in at lightning speed, all those little twitches fuse together into one smooth, powerful, and sustained contraction. That's called tetanus, and that's your muscle going all out. All right, so we can change the number of units, and we can change how hard they fire. But there's another layer to this. It turns out that not all muscle fibers are created equal. It's like your body has a built-in toolkit with different tools for different jobs. You've actually got different types of fibers all mixed in there inside your muscles, each one with its own special talents. The best analogy is thinking of a track team. You've got your marathon runners, your middle distance guys, and your explosive sprinters, all on the same team ready to go. And here are the three main players. You've got your type 1, or slow twitch fibers. They don't produce a ton of force, but man, they can go all day. They're your endurance champs. On the other extreme, you have type 2X fibers. These are the pure powerhouses, producing huge force, but they burn out super fast. And right in the middle, you have the type 2A fibers, which are kind of the jack of all trades. And this quote really just nails it. The mix of these fibers you have is a huge factor in what you're naturally good at. Someone with a higher percentage of those fast-twitch, type 2X fibers has a built-in advantage for generating that explosive peak force. All right, we're at the last dial on our control panel, and this one is all about pure physics and good old-fashioned mechanics. It's not just about what's happening inside the nerves, it's about the physical position of the muscle itself. Every single one of your muscles has what we call an optimal length. This is the absolute sweet spot where all the tiny little protein filaments inside, the actin and myosin, are lined up perfectly. This perfect overlap allows them to form the maximum possible number of connections, and those connections are what actually generates force. Now, if the muscle is too short, all scrunched up, those filaments get in each other's way and they can't connect properly. And if the muscle is stretched out too far, they're too far apart to grab onto each other. Either way, your ability to produce force just tanks.
And you can see it right here. Force is at its absolute maximum, right at that optimal length, but it just plummets on either side. This is exactly why your form and your joint angles are so important when you're trying to lift something heavy. You're instinctively trying to find that mechanical sweet spot.
And there you have it. Those are the 4 key controls on your muscles performance panel. When you put them all together, you really start to see this beautiful, complex picture of how your body creates movement. So to recap the whole thing, your brain is making all these decisions at once. First, recruitment. How big is the team? Second, stimulation rate. How hard are you telling them to work? Third, fiber type. Are you sending in the sprinters or the marathoners? And finally, muscle length. Is everything positioned in that sweet spot for maximum power? When you really think about it, every single thing you do, from hitting a key on your keyboard to a huge jump, is a quiet little masterpiece of coordination. It's this amazing biological symphony, with these 4 factors all working together perfectly, happening inside you all day, every day.
And that brings up a really interesting final thought, doesn't it? Now that you know about this control panel, how does that change how you think about working out, or rehabilitation, or even just how you move? How could you start to consciously train these different factors to get stronger, faster, or just more efficient? It's definitely something to think about.